In today's video, we will look at Ohm's law, we will look at some resistor basics, and we'll look at Kirchhoff's voltage and current laws, and this is the theory part. Please refer to my next videos for examples on these if you do not wish to look at the theory part. Okay, so what is a resistor? A resistor, as the name suggests, resists flow of electric current. So how does it do this? Well, if you think of an element which conducts current, then it will usually be a wire which is cylindrical or round in nature. And it'll have some length. It'll have some cross-sectional area opposite to the length. And it'll have some what is known as a resistivity rho. This symbol is rho. So the resistivity varies from material to material. It is usually given in a table for example, copper. And the formula for resistance based on this diagram is rho, the resistivity, times the length of the material divided by the cross-sectional area over here. And we represent a resistor in circuits by the squiggly line here. We represent it with the value R, which is some value such as 50 or 60 or 100, and the units for this value is what is known as ohm, and the symbol for that is that one there. Okay, so we get different resistor types. We get constant resistors and we get variable resistors. A constant resistor says consistent. No matter what the value of V is and I is, it is always the same value. A variable resistor can vary between different resistances, depending. You can buy different types of variable resistors which will vary between different values, and this is the graph, what it will look like if you were to plot voltage versus current for a variable resistor. And constant resistors obey Ohm's law, which we'll look at next. Okay, next we look at the reciprocal of R. The reciprocal of R is conductance. A resistor resists the flow of electric current, so it's the resistance of electric current. Conductance is an element's current conducting ability. This is its resistance ability. Hence the fact that they're inverses or reciprocals of each other. G equals 1 over R, and the unit for that is mhos, ohms, mhos, or Siemens. Okay, next we look at Ohm's law. So what is Ohm's law? Ohm's law says that the voltage of a resistor is directly proportional to the current through that resistor. So, how can we write that in a formula? The formula is V equals I times R. So the voltage is equal to the current times the resistance through that, or for that resistor. And as you can see, the voltage is directly proportional to the current. Other forms for it, if you just divide through by I on both sides, you will see that R equals V over I. Or I is equal to V over R. All I'm doing is dividing by either I on both sides, like in this case, or by R on both sides, like in this case. So that's Ohm's law. Then we look at some circuit types. You either get a short circuit or an open circuit case. Of course, there are in-between cases, but I'll explain now. So a short circuit is something like this. So as you can see, current would just be able to flow straight through. So what does this imply? This implies that the resistance here is 0. So now we say, okay, well, we can look at Ohm's law, which says V equals IR. And of course, if you multiply by 0, if R is 0, then your voltage is just going to be 0 there. So the current can flow freely. Current can be any value you want to make it, and it will flow straight through. An open circuit, on the other hand, looks something like this. Okay. So as you can see, there's no wire there. There's no space for current to flow. There's maybe a wire, but there might just be an element that makes it the current cannot flow there. So that implies that R equals infinity. The resistance is infinitely big, always tending toward 0 and tending toward infinity. So that means V equals IR again, which is I times infinity. So no matter what I is, you'll have infinite number of volts. There's no current flowing through there, so I equals 0. No current. I equals anything actually. My apologies. There's no current flowing through there, no matter what I is. So next we look at power in resistors. Power and resistors. So the reason I left this out was because we first needed to look at Ohm's law in order to do this. So P equals VI, that we know from the previous videos. Power is the voltage times the current. But we also know that V equals IR. V equals IR from Ohm's law. But now I can say, okay, well, we have V over here. So can't we sub this in over there? Can't we say P equals IR times I, which if you multiply those, it would be I squared R. So in a resistor, obeying Ohm's law, of course, so a constant resistor, the power would be equal to I squared R. But you can also write this in a different way. You can also say, but I is equal to V over R from Ohm's law, in which case power would be equal, P equals VI, you would sub in for I, so that would be V times V over R, which would be V squared over R. A note to make about this is that resistance is always greater than 0, because you cannot get negative resistance, which also implies that the power in a resistor is always greater than 0. Okay, so next we're going to look at some different circuit parts. Just organizing myself. Okay, so we're going to look at some different circuit parts. The circuit parts that we're going to look at are known as nodes, branches, and loops. So what are these? You get nodes. Nodes are the connections between the different elements within a circuit. Okay, so nodes are, for example, this is a node by itself. This over here is one huge node. So this circuit basically has 1, 2, 3 nodes. 1, 2, 3 nodes. Okay, then we look at branches. A branch is any element in the circuit. So for example, a resistor is a branch, a source is a branch, a dependent source is a branch. So this is a branch, this is a branch, this is a branch, this is a branch. So in this case, there are 4 branches in this circuit. And next we're going to look at loops. A loop is any closed path from a point A to that same point A. So a loop, for example, is from here, this point in the circuit, all the way around back to that same point. So that's one loop. Then here is another loop from that point back to that point. And a big loop would be from this point all the way around like that back to this same point. In this case, there are 3 loops. Okay. Now, formula in circuits for this is the number of branches will be equal to number of loops plus the number of nodes minus 1. So if you're given these two, then you can work out the number of branches. If you've given the number of branches and the number of nodes, you can work out the number of loops. And yes. Okay, so let's look at a quick example. We're given the circuit and it has a 10-volt power supply, DC power supply, and we're given that there's a current I through some resistor of 10 ohms and there's some voltage over this resistor. And we're asked to calculate the current, the conductance, and the power. Okay, so what are we given? We want current, so current, and we are given a voltage of 10, and we know we have a resistance of 10 ohms. So we can say V equals IR from Ohm's law. So we want to work out current. So I'm just going to say divide by R on both sides, which gives you V over R. And we have voltage 10. We have resistance 10. So current is 1 ampere. Okay, so that already solves the first question. Next, we're asked to work out the conductance. Well, what do we know about conductance? The conductance is just the reciprocal of R. G is its symbol, 1 over R. Okay, so what's the resistance? The resistance is 10, which gives us 0.1 mhos, or 0.1 Siemens if you wish. Okay, so next we're asked to work out the power. Also, there's something else to note here, is the fact that there's only one resistor in this circuit. So if 10 volts is given, that 10 volts has to be used up according to KVL, which we'll learn later. So this 10 volts has to be used up here, so this V is 10 volts, just to take note of that. So the power is equal to V times I. Already worked that out. And that voltage over here is 10 volts, over there 10 volts, and the current is 1 ampere, which gives us 10 watts. Okay, next we look at what I just mentioned, Kirchhoff's laws. So Kirchhoff's laws, you get two laws. You get a current law, which is known as KCL, Kirchhoff's current law, and we get a voltage law, KVL, Kirchhoff's voltage law. Okay, so what are these? The current law states that the sum of all the currents into or out of any specific node is equal to 0. So whatever comes into a node must go out of that node. So that means the sum of all currents in minus the sum of all the currents out must equal to 0. And it can also be the opposite way around, so vice versa. So whatever goes out minus whatever comes in must be equal to 0. So let's look at an example of this. X, 2 points X and Y. And we have some current sources. I'm just giving them some values. 4 amps, like that, let's say. Okay, so what can we say about this? Well, let's first find our node. So this is a single node here, and all these currents are coming into this node. So we just said that the sum of all the currents must be equal to 0. So we are going to prove that it's equal to 0. So what's coming into this node? Well, 3 amperes is coming in. We're going to take what's coming in as positive, as here. Then 1 ampere is going out. Okay, wait. Where's I total here? I total. There must be a current leaving in that direction because it's part of the node. Plus 4 is coming in. And minus I total, which is going out, equals 0. Okay, so now we can say, okay, 3 minus 1 is 2, plus 4 is 6. So 6 minus I total equals 0, and 6 amperes equals I total. So what does this mean? This means that I total leaving here is equal to 6 amperes. So if you look at this, 3 amperes is coming in, minus 1 is 2 amperes, plus 4, which is coming in, is 6 amperes. So 6 amperes is coming in total, and 6 amperes is leaving in total. So that means the sum of everything is basically 0, as we said. Then we look at Kirchhoff's voltage law, which states that the sum of all voltages in a loop must be equal to 0. So whatever voltages you find in a loop must be equal to 0. So let's look at an example of this so you can understand what I'm saying. So if we have two sources like this, let's say 3 volts and 5 volts, and we have a few resistors. Don't stress too much about it, it's just resistors. Okay, so now we said the sum of all the voltages within a loop must be equal to 0. So let's draw a loop. That is a single loop. There's only one loop in this circuit. As from there's 3 loops, here's only one. Okay, so we can add all the voltages in this loop. So let's start with this source here. So if we come from this side in this source, we will see minus 3 volts plus V1 plus 5 volts minus V2 minus V3 minus, and we said it must be equal to 0. And in this way we can solve for a certain voltage if we have to within a circuit. Thank you. That is my theory video. Please check out my next video, which will be examples based on everything done in this video.